the sum, difference, and product of two functions. You're accustomed to looking at these ideas that we represent as, say, f of x or as g of x as being complicated ideas. And in one sense, they are. They're f of x and g of x are instructions on how to calculate a value given some starting point. But in another sense, f of x is a placeholder for a real number. Once you choose a value of x, you turn it into the function, it spits out a number. So the function f of x can be treated as though it were a real number. And so if we have a real number called f of x and a real number called g of x, we can do things with those the same as we do with any other real number. Common things you might try to do are add the real numbers together, subtract the real numbers, or multiply them. And for convenience in working with functions, because we can do this in general with the rules, and then use the new rule as a new function, we often use a shorthand notation. Right. F plus g of x is the function formed by taking f of x and g of x and then adding them together. Once you have a value of x, you plug it into f and g separately, you add them together, it spits out a result. It's a nice, well-defined rule. If, for example, we have a couple of functions that we know things about, let's say that f of x is 3x squared and g of x is 4x minus 3. And I use square brackets to distinguish the brackets containing f plus g and the bracket containing x. Some sources use parentheses instead. It's the same basic idea. But f plus g of x, we define that to mean f of x plus g of x, and substituting in, f of x is 3x squared, g of x is 4x minus 3, and when we add those together, well, adding doesn't actually do much interesting in this case. We get the result of 3x squared plus 4x minus 3. Taking those same two functions and just continuing down the list, if we have f minus g of x, well, by definition, that is f of x minus g of x. And here is where that habit of always putting things in parentheses when you substitute a value into an expression pays off. Because we have to be careful to distribute the subtraction there. And end up with 3x squared minus 4x plus 3. All right, one more, multiplication. If we want to take a look at fg of x, well, by definition, that is f of x times g of x. And by substitution, that's 3x squared times 4x minus 3, which is 12x cubed minus 9x squared. Right? There we have it, expressions for f plus g, f minus g, and f times g. If you're asked for a particular value, you can shortcut a lot of this by plugging the values in immediately and going from there, or you can work out the general expression anyway. If you're asked about the domain or range of a function, we have an expression for the function, and you can analyze domain and range there the same way you would analyze domain and range of a expression you had in the first place. But for the questions right now, you'll be asked simply to evaluate some of these functions and come up with these expressions.